Enjoy the lesson and pay attention. I'll be keeping an eye on you.
Hey everyone, and welcome to another electrifying lesson on TIBCO BusinessWorks. In our previous episodes, we laid the groundwork, learning how to structure processes and exploring fundamental shared resources like shared variables and the data format, the latter being indispensable for integrating systems via files. But today, we're leveling up. We're diving into another crucial shared resource, the JDBC connection. We'll discover how to use it, along with a set of powerful activities to read, insert, and modify data directly in your databases. And don't leave before the end. I'll reveal a time-saving trick for inserting a ton of data in one go in batch. This is the first shared resource that takes us beyond the boundaries of BusinessWorks, as it requires a real connection to an external server. The JDBC connection is, in essence, your passport to communicate with any database. For our demo, we'll be using PostgreSQL. I've already set up a people_db database with two tables, address for addresses and person for personal details, featuring a foreign key linking each person to their address. I've populated it with 10 unique individuals, each with their own distinct address, giving us plenty of data to work with. As our first practical example, we want to retrieve all individuals born before 1990 directly from our Bavo application. In our dataset, we'll find 7 such people, for instance, Luca, Jane, Emily, and others. Let's start by configuring our JDBC connection. First, we'll create it within the Resources folder package. You'll need your database server's username and password. The first is usually visible in the properties, while the password is set during installation. Keep attention even for host and port. Of course, we'll select the PostgreSQL driver. For the database URL, as shown in the properties, we'll set localhost and the port 5433, along with the database name. A simple click on Test Connection will immediately tell us if the connection is successful. As always, we'll organize our processes into logical layers. We'll create the JDBC package with the getPersonYear process within the integration layer, and don't forget our useful logging structure. The key activity for retrieving data is the JDBC query. We need to link it to our JDBC connection. Note the timeout and maximum rows settings. We'll set maximum rows to 0 to retrieve all records, not just the first 100. In the statement section, we'll write our SQL query. A golden tip: always define the specific column names you need instead of the generic asterisk. This makes the process more robust and clear. We'll then insert the filter for individuals born before 1990. Important: the output won't be visible until it's properly fetched, as the data is extracted and presented as an XML document. This output isn't just a simple list. It's a full-fledged XML document that encapsulates all the records extracted from the database. Pretty cool, right? But why not make the process even more dynamic and reusable? Instead of hard-coding the year directly into the query, let's add a parameter. We'll create a year parameter of integer type. The query understands where to insert parameters thanks to the question mark symbol. Let's replace with year. If we had multiple parameters, we'd use multiple question marks in sequence, and BV would substitute them in the correct order. You'll then see the parameters added to the activity's input. Now, let's define the input and output of our process using an XSD. The input will be the year, and the output an array with the fields returned by our query. We'll start and map the year to the query's input and the returned records to the process's output. Just like the data format, the JDBC connection is also referenced in the process properties. Next, we'll create our operation process. You can copy an existing one and clean it. We'll add the call to our getPersonYear process and pass 1990 as the input. Finally, a main process will kick things off with a timer and invoke our flow. Let's run the debug. And there you have it, all the people born before 1990. What if we wanted to retrieve people born in a specific city? Nothing could be simpler. We'll duplicate the getPersonYear process and create a nested query that filters by city, using another question mark for the city parameter. We'll reference a string as input to both the process and the query. In the operation process, we'll then call this new process, passing Rome as the city. Let's run the debug. And voila, all the people living in Rome. We're exploring TIBCO's functionalities together. If you have any questions about what we've covered so far or suggestions for future tutorials, leave them in the comments below. And if you haven't already, subscribe to join our community. Now, let's move on to writing to the database, starting with the update operation. Imagine a Robert Johnson is wanted. He needs to change his name to Gary Clark, and to stay hidden, he'll move undercover to his friend Olivia Miller's place. So we'll not only change his first and last name, but also his address ID, taking Olivia's. We'll create a new process and insert the JDBC update activity, our gateway to writing data to the database. Here too, we'll craft our SQL query, the goal? To update a person's first name, last name, and optionally, their address ID, all based on their person ID. We'll use question marks as placeholders for the parameters in order: first name, last name, and the address ID to modify. Remember, IDs will be of integer type. The defined parameters will be expected as input for the activity, so we need to define them in the schema for input to the process. We'll make first name and last name mandatory, but the address ID will be optional. We only want to update it if provided. We'll map the start activity's input to the update activity. The output will tell us how many records in the DB were updated. In our case, we expect just one. But be careful, if the address ID is not provided, the activity might insert null into the DB, if allowed, or throw an exception. To handle this, we'll duplicate the update activity. One version will update the address as well, while the other will only update the first and last name. We'll use transitions to branch the logic. If the address ID is present, we use the first version, otherwise, we use the second. We'll then call the process in the operation, providing Robert's new first and last name, Gary Clark, his ID, and Olivia's address ID. Let's run the debug. Checking the database, we'll see that the person with ID 3 is now named Gary Clark and has Olivia's address ID. Mission accomplished. Finally, let's look at insertion. Imagine we have new addresses to add to the database. We'll create an insert address process. The activity we need is always the JDBC update. We'll modify the statement for an insert query. Remember that the ID is a serial field in PostgreSQL, so it will be automatically generated. We'll insert the values for the columns, using question marks for the parameters in sequential order. The parameters we've defined are for a single record. But as I promised, we want to insert multiple addresses at once. This is where batch insertion comes in. Simply go to the advanced section of the activity and check batch update. These fields will need to come from the process's start activity, so I already created the XSD element and map it to the insert activity's input. We'll then call the process in the operation process. Insert Trey Cosula's addresses on in Madrid other in Paris, and another else in Berlin. Let's run a test. We'll see that 3 records have been inserted. Checking the database, here are the new IDs, 11, 12, and 13. Batch insertion works great. That's all for today, but don't go anywhere because in the next lesson, we'll explore other powerful activities for interacting with the database, SQL direct and call procedure. We'll also see how local transaction and critical section groups can be used to best manage database operations. And to challenge yourselves, here's an exercise. Try implementing batch deletion. Given a list of person IDs, delete them from the person table, and if their associated addresses are no longer linked to any other individual, delete those records from the address table as well. A little hint, deletion can also be done with the update activity, but using a delete query. I hope this tutorial was helpful. If you encounter any difficulties with the exercises or have any questions, write them in the comments below. See you next time.